Since we had learned about the trigonometric ratios of the complementary angles, now we'll look on some examples of them. So here's the first example, which says that we have to find the value of cos 52 degrees minus sin 38 degrees. Now if you look on these angles, 52 degrees and 38 degrees, can you tell me what is the value of cos 52 and what is the value of sin 38 by looking in the table? No, you can't, because we had learned the trigonometric ratios for only 5 angles. Those were 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. So we had learned the trigonometric ratios for only 5 angles. So we can't find the values of these two and then solve. We can't do that. But we have to solve these. So what's the procedure? If you look here at the angle only, this is 52 degrees and this is 38 degrees. And if you add these two particular angles, we'll get 90 degrees. So we can say that 52 and 38 are complementary angles. And we know that how to deal with the trigonometric ratios of complementary angles. So if I take cos 52, I can write it as cos of 90 minus some angle, and that angle will be 38 degrees. Can I write it this way? I hadn't changed anything. I had just broken this particular angle 52 in 90 minus some angle format. So basically, if you want to change this angle, all you have to do is break this angle in 90 minus some angle format, and then we know when our angle is written in this format, that 90 minus some angle, the trigonometric function changes into its complementary trigonometric function. So cos will change into sine and that particular angle will remain. So this will be converted into sine of 38 degrees. So all we have done is we had broken this angle in the terms of 90 minus some angle format, and that particular angle will be complementary to 52 degrees. That means the sum of 52 and this angle must be 90 degrees. So now we can change this function cos of 90 minus some angle into its complementary trigonometric function, that is sine of that angle. Now we can solve it. So this will become sine of 38 degrees minus sine of 38 degrees. In place of cos 52, we had changed it into sine of 38. So these will get cancelled out and will get 0. Now let's move on to our next example. Next example says that we have to express sin 67 plus cos 75 in terms of trigonometric ratios between angles 0 and 45. Now we had seen that we can break any angle in terms of 90 minus its complementary angle. And to find the complementary angle of any particular angle, what we have to remember is that the sum of complementary angles is 90 degrees. So if we have to find the complementary angle of 67, then we have to subtract 67 from 90 degrees. And if we have to find the complementary of 75, then we have to subtract this 75 from 90 degrees. So let's first find out the complementary angles of these two angles. Complementary angle of 67 degrees will be 90 degrees minus 67 degrees. So this comes out to be 23 degrees. Similarly, we can find out the complementary angle of 75 degrees. So we'll subtract 75 from 90. So this will be 90 degrees minus 75 degrees. So this will come out to be 15 degrees. Now since we had calculated the complementary angles of both these angles, we can write the sine term into sine of 90 minus their complementary angle, and we can write this cos term into cos of 90 minus its complementary angle. Why we are doing it? Because we can write the complementary angle of any trigonometric function is the complementary trigonometric function of that particular angle, and we can break this angle into 0 to 45 degrees. So let's see how we are going to do it. We can write sine 67 plus cos 75 in terms sine of 90 degrees minus this angle 23 degrees, and plus cos of 75 can also be written into 90 minus the complementary of 75, that is 15 degrees. Now if you look at these two terms, this is written in the form of trigonometric function into trigonometric function of 90 minus some angle. So this can be changed into its complementary trigonometric function and that angle. This we had learned earlier. So let's write down sine complementary trigonometric function is cosine. So this will change into cos of 23 degrees. Only this angle will remain, and similarly cos will change into its complementary trigonometric function, that is sine. So this will be sine of 15 degrees. Now if you look, we had changed sine 67 in 0 to 45 degrees and also cos 75 into 0 to 45 degrees. So this is our final result. Now let's move on to our next type of examples. In this example, we are given some trigonometric function is equals to some other trigonometric function, and we have to find the value of angle A. Now if you look closely to this question, here it is written that cot of 2A is equals to tan of A minus 18 degrees. Now if any trigonometric function is equals to its complementary trigonometric function, that means that their angle sum must be 90 degrees, or we can say that their corresponding angles are complementary angles. So we can say that 2A and A minus 18 are complementary angles, and if they are complementary, then their sum must be equals to 90 degrees. So we can say that since cot of 2A is equals to tan of A minus 18, we can say that 2A and A minus 18 are complementary angles, and if they are complementary to each other, their sum must be equals to 90 degrees. So we can write down 2A plus A minus 18 is equals to 90 degrees. Now we can solve it. So let's solve it. This will be 3A, and take this 18 on right hand side. This will become 90 plus 18. So this will come out to be 3A is equals to 108 degrees, and if you calculate the value of A, this comes out to be 36 degrees. We divided this 3 in our right hand side and we get 36 degrees. So this is how we get the value of angle A. All we had done is that if we look at this relation, we had find out that these two trigonometric functions are complementary to each other, and if two trigonometric functions are complementary to each other, then their angle sum must be 90 degrees. That means their angles will also be complementary to each other.